A poll is given showing 80% are in favor of a new building project. If 9 people are chosen at random, what is the probability that exactly 8 of them favor the new building? All right, so first off, anytime you're given a probability of success, okay, so 80%, that is a probability of success. And then you're given a fixed number of people, so we have 9 people are chosen, and you want to know that exactly 8 of them are in favor of the new building. That's going to be a binomial distribution problem, and you have the link right over here. So click on the link, and it'll take you to this page over here. Now we have to put in our variables. So let's take a look at our variables. The probability of success is 80%. So the probability is going to be 0.80. N is the number of selections, so we have 9 people that are selected, so n equals to 9. And we want to know that out of the 9 people, what is the probability that exactly 8 of them favor the new building? Okay, so imagine that 9 people are selected. And now out of the whole population, 80% favor a new building project. So the question is, if you select 9 people, what is the probability that 8 of them are going to say, yes, I favor the new project? So we put in these variables. Okay, we're going to go to our binomial calculator. We're going to click on find probabilities. That's important. The number of trials is 9 because 9 people are selected. The probability of success is 0.80. And we want to know that exactly what is the probability of getting exactly 8 people that favor the project. And that is going to be 0.3020. A manufacturing machine has a 2% defect rate. If 9 items are chosen at random, what is the probability that at least one will have a defect? Okay, so first off, let's define our variables. We are choosing 9 items, so n is going to be 9. The probability, in this case, a success is defined by any machine that has a defect. Okay, so that's what we consider a success. And that probability is 2%, which is 0.02. Now we want to know, what is the probability that at least one will have a defect? Well, at least one, it means one or more. So we're going to say we want to find the probability that one or more have a defect. Okay, so the at least is going to be greater than or equal to. Now let's go to our calculator. The link is right over there, and put these in. So our n is going to be 9 because we are selecting 9 items. The probability of success is going to be 0.02 because there's a 2% success rate. And you got to select the correct inequality. We're going to select greater than or equal to because we want to know probability that at least one has a defect. And that probability is going to be 0.1663. So this means if you are taking batches of 9, 9, 9, 9, 9, etc., you do that 100 times, then about 17 out of those 100 are going to have at least one with a defect. Okay, so that probability is going to be 0.1663. If a seed is planted, it has a 70% chance of growing into a healthy plant. If 7 seeds are planted, what is the probability that exactly 4 don't grow? Now this is kind of tricky because the 70% chance, that's a chance of growing. However, we want to find the probability that they don't grow. That's how we define a success. Okay, so let's start with the easy part. 7 seeds are planted. So our n is going to be 7. Now here's where you have to be careful. In this case, we define a success as seeds that don't grow. So the probability of success is not going to be 70% because those seeds do grow. We want to know what percent of them don't grow. So if we take 100% minus 70%, that'll be 30%. That is going to be our true probability of success because 30% of them do not grow. So P is going to be 0.30. Okay, and then exactly 4, that means we want to know the probability that x equals to 4. Now let's click on our link and go to that calculator. N is going to be 7. The probability that they do not grow, now remember, this is not that they grow, that they do not grow, is going to be 30. And we want to say what is the probability that x is exactly equal to 4, because we want 4 of them to not grow, and that probability is going to be 0.0972. Assume that a procedure yields a binomial distribution with the trial repeated n equals 17 times. This one is nice. They even give you what n is. N equals to 17. Use either the binomial formula. So we're not going to use a formula. We're going to use technology. And the technology link is right over here. To find the probability of k equals to 3. Successes, given the probability of a failure, is 0.72. So again, this is kind of tricky. Q is the probability of failure. However, we want to know what is the probability of 3 successes. So if the probability of failure, which is Q, is equal to 0.72, then the probability of success, which is P, is going to be 1 minus 0.72, which is going to be 0.28. So you got to be very careful here. Probability of success is going to be 0.28, not 0.72. Okay, now we want to find out what is the probability of getting exactly 3 successes. So we're going to click on that link to get to the binomial distribution. And n is 17 because we have 17 trials. The probability of success is going to be 0.28, not 0.72, that's failure. Success is going to be 0.28. And we want to know what is the probability that exactly 3 of them fail. So we're going to say x equals to 3, and that probability is going to be 0.1502. Okay, so probability that x equals to 3 is going to be 0.1502. After being rejected for employment, Kim Kelly learns that the Bellevue Credit Company has hired only 3 women among the last 21 employees. Now that's kind of unusual, right? If you're hiring 21 employees, how is it that only 3 of them are women? That seems kind of suspicious. So she learns that the pool of applicants is very large, with an approximately equal number of qualified men as women. So theoretically, because we have an equal number of qualified men and women, the probability of hiring a woman is 0.50. It should be 50-50. Okay, so help her address a change of the charge of gender discrimination by finding the probability of getting 3 or fewer women when 21 are hired. All right, so let's go through and put our variables down. 21 people are hired. So N is going to be 21. N is the number of people that were hired. Now, probability isn't given to us, but remember, we have an equal number of qualified men and women. So out of 21, half the new hires should have been women. So P is going to be 0.5. Now we want to know what is the probability that we have at most 3. So when you have at most, the inequality is going to be less than or equal to. We want a maximum of 3 women in this case. That's what happened. That's how many were hired. So we want to know the probability that X is less than or equal to 3. Okay, let's click on the binomial distribution calculator, go to our link, and plug these in. So n is going to be 21. Now probability, half of them should have been women, so p is going to be 0.50. Now the question is, what is the probability that at most is going to be less than or equal to? That at most 3 women were hired. That probability is 0.00000007. So if this was done fairly, there's only a 0.0007 probability, that's 0.07% of a probability that only 3 women should have been hired. This is very unusual. It's very unusual to hire 21 people and only hire 3 women. That's very unusual. Okay, that probability is 0.0007. So because this is a serious claim, we want to know if this is unusual. So we're going to use a 5% as a cutoff value, which means if the probability is less than 0.05, then that's considered to be unusual. Now this probability is 0.0007, so 0.0007, that's definitely less than 0.05. So it's unusual for this to happen, which means the reason it happened is because they were using gender discrimination. The television show Pretty Betty has been successful for many years. That show has a share of 18, meaning that 18% were tuned to Pretty Betty. All right, so assume that an advertiser wants to verify that the 18% share by conducting their own survey. The pilot begins with 14 households. So 14 households, it means that our N is going to be 14. Okay, N is going to be 14. So 14 households were surveyed. 18% of them should have been turned to Pretty Betty. So our probability is going to be 0.18. Of those 14 households, 18% should have been tuned to Pretty Betty. So our probability is going to be 0.18. Now part A says, find the probability that of these 14, none of them were turned to Pretty Betty. So in the first part, we're going to say what is the probability that x is equal to 0. In other words, nobody was watching Pretty Betty. So N is going to be 14. That's how many households were surveyed. 18% of them, or 0.18, should have been tuned to Pretty Betty. We want to know what is the probability that x is equal to 0, that nobody was tuned in. And that probability is going to be 0.0621. Okay, so for part A, that probability is going to be 0.0621. Now part B says, find the probability that at least one household was turned to Pretty Betty out of those 14. Now the word at least, or the phrase at least, that's going to be greater than or equal to. So it's going to be 1 or more. So for part B, we want to know what is the probability that x is greater than or equal to 1. So we have 14, 0.18, and greater than or equal to 1. That probability is going to be 0.9379. So out of 14 households, there's a 94% probability that at least one of them was turned to Pretty Betty. Okay, 0.9379. Then part C says, what is the probability that at most one household is turned to Pretty Betty? So at most, that's going to be less than or equal to. That'll be the inequality. So we want to find the probability that x is less than or equal to 1. At most is less than or equal to. Okay, so once again, we have 14 households, probability is 0.18. This time we want to know probability that that's less than or equal to 1, and that probability is 0.2531.